Hello guys, welcome to the new video. My name is Sajiyah and today we will learn about Docker. So let's understand Docker by an example. Imagine you have got a application in Python, right? You have the source code, right? You have tried it on your local machine and it's working fine, right? Now you want to send this code base to your friend and you are like just check it the code base and let me know how it works and how it made, right? Now your friend is trying to run the code base and it failed. Now you are like, it's running on my PC. I've checked twice. Why it's not running on your PC? Then you go to know, and your friend says, this is an error. It says this is missing. This library is missing. That is missing. Now you understand the basics. You understand what's missing. You understand the library which you have used in your code base is missing on your friend's laptop. There are many libraries you have used in your code base, and installing one after another on your friend's PC and then running the code base is tough task to do. Right? Now what I want to do, I want to pack the source code. I want to make a box and I want to have a source code. In it. Code and the local environment. I want to send this to my friend. Is it possible? It would be highly easy for him to run the code if it is like that. Yes, it is possible. How? It is possible with the help of Docker. Okay? It's possible with the help of Docker. It's possible with the help of containers. Okay. Now, what are containers? This box in which I have packed the source code and the local environment is containers. And a company who is managing these containers is Docker. Okay. For simple term, just consider this. For now, just consider this. Okay. Let me explain you with another example. Imagine you have a company, Lay's company, just Lay's. Lay's chips comes in a packet which have chips basically and the nitrogen gas. What's the job of nitrogen gas here? Nitrogen gas will keep the chips fresh. It will be like if you open the package and it will be fresh, right? The job of nitrogen gas is simply to keep the chips packed and fresh. Okay. Here we can understand this as chips as source code. We can understand chips as our source code. Source code and nitrogen is local environment. Hope now you got the clear idea. See, now what is Docker Hub? Let me explain you what is Docker Hub. Before that, let me explain you other thing as well. Now you got my point, right? Now our container is ready, right? Now I want to deliver this container, this box, to my friend, right? We have packed the box. Now there should be someone who can deliver this box. There comes our Docker Hub. From Docker Hub is simple like GitHub. On GitHub you can post your code online, right? In Docker Hub you are posting your code as well as a local environment packed in a box, just as GitHub. But there is the addition of local environment on Docker Hub, right? Hope you got it. Now let me show you Docker Hub as well. Okay, so we got a clear idea about containers. What is containers? Containers is simply a box in which we packed our local environment and source code, right? For now, just understand this. It's much more than that, but still, for beginners, if you are just starting out, just understand this. Okay, you will learn it as you grow. Okay, so let's understand another thing. How containers become so famous, how containers are so important, why containers are so useful. In back 2000s, there were applications. There were people using the applications and there were deployments, right? There were deployments without containers. Why we can't do the same thing for now is the question, right? Let's understand this by an example. So in early 2000s, we have a traditional deployments, or I think before that, I'm not sure about the timeline, but let's understand this. The traditional deployments. So if you have an application, you need to run up your, you need to buy a physical server, and you can run a operating system on it, and then you can spin up your application, right? If you want to spin up hundreds of applications, you need to buy hundreds of physical servers. You can't spin up hundreds of applications on one physical server. That was the idea. But as the audience grow, as people using application grow, this technique fails, right? Okay, so let's move to virtualized. Then, after 1990 to 2001, we had a virtualized deployment. The company named VMware, it's still there. Company named VMware came up with the idea of virtual boxes. What is a virtual box? It's an isolated environment in which you can spin up your operating system and then you can spin up your application. So the idea was like that. So idea was physical server. You can buy your physical server and on the physical server run your operating system. But here you can run up 2 to 3 operating system or more depending on the size of your physical server, and you can run your application on one operating system. For another application, you need to use another operating system. For another application, you need to spin up another operating system, right? But you can run different application and multiple application on same physical server. So this was a feature in early 2000s. Guest operating system. But this was an isolated environment, and this was good. It was running as well, but we need to partition the memory. We need to allocate a memory. If I have a 8 GB, you need to give 2 GB here, 2 GB here. If you have ever done a dual boot in your PC, you would know what is a partition, or you have ever spin up a virtual box by allocating a memory. You would know what is virtual box memory taking and all. If you have ever had a Minikube experience, if you know about Kubernetes, you would know about memory allocation of 4 GB or 2 GB, right? So that was the issue. You need to allocate a memory, and it was taking a huge amount of memory, right? To spin up a operating system. For now, Windows operating system is of 6.1 GB, right? So you can imagine how heavy it is, right? On one operating system, you can't run multiple applications. Another issue is you can't run multiple applications on one operating system, right? Also, memory issues as well. So this also fails. As user increase, as the deployment increase, this fails. Now, wait for a minute. Let's remove it to understand it better. Okay, so there is an issue. No worries. Okay, so then in 2008, Docker introduced containers. Docker introduced containers from Linux server by taking idea from Linux. Containers came into existence. So what's the idea of containers? Buy a physical server, run operating system on it, and now here's the catch. Instead of hypervisor, run Docker engine. And you don't need to run different operating systems. You will have an isolated environment in form of a small boxes known as containers. And these containers are really lightweight. Like as I told you, Windows operating system is for now 6.1 GB. This is hardly 14 MB or something, right? Some of the images or some of the containers are even 1 MB, 2 MB. It's literally lightweight, right? Where is 6.1 GB and what is 14 MB? Can you see the difference? It's a huge difference, right? And you can run a multiple containers on one operating system. You don't need to spin up another operating system as well. And memory allocation issues are solved as well. So now we are on containers. And I'm pretty sure as we will move forward in 2030 to 2035, there will be new technologies as well, because DevOps is a field which is continuously evolving. In this time, there will be a person who will introduce a new feature in Kubernetes, or Kubernetes is evolving so fast, it's growing daily, right? This Docker is growing daily. There are many contributors contributing to it into daily basis, like removing bugs and features, right? So these technologies are evolving as fast as possible because they are open source, right? Many members and many contributors and maintainers are working on it right now. So this is the process of the container deployments. Hope you understood the traditional deployments, how we came from a traditional deployment to virtualized deployment, and from virtualized deployments to container deployments. Let me give a revision as well. So on traditional deployments, we have a physical server, operating system, and you can run one application on one physical server. For another application, you need to spin up another physical server. For virtualized deployments, you can run one physical server. You can run up 2 to 3 applications. But the catch here is you need to have an operating system for different application, and memory allocation issues, and operating system space issues. Then we have a container deployments, we have a physical server, operating system, and instead of hypervisor, we have a Docker engine, and we can run multiple applications in isolated environment without spinning up our operating system, and memory issues is solved, space allocation issues is solved, and it's lightweight in nature, so everything is done. Everything is good with container deployments till now. Let's wait for new technologies. Okay, hope you got the idea. Let's move forward to learn more about Docker and Docker Hub. Okay, so you got the idea about this. Let's move to this. So in 2000, Jails 2000. So let's understand how containers evolve with companies, right? How companies came with an innovation of Docker. So Jails in early 2000 and 2000s, Jails got idea of isolated files, how to isolate files, right? And then Linux in 2001 came up with a ports and kernels and isolations. Ports you would know 8080. We will run our Docker containers on 8080 port in further lecture. And then Solaris bring the concept of snapshot. Snapshot concept is simple. It's simple. It's like you took a selfie, right? So that moment is captured in a selfie. It's the same thing here. You have a database and you took a snapshot. Now this snapshot will remain as it is. And if your database is corrupt and it's of no use for now, so you have a backup in the form of snapshot. Let's not go deep into snapshots right now. If you want to learn, you can search it on your own. Okay, then Google introduces containers. Google introduces processes and containers. Okay, so it was Google who was first introduced containers here. And then Red Hat namespaces. Many of you would not be familiar with namespaces. Namespaces is much of a topic of Kubernetes. You will learn more about namespaces in Kubernetes. Like namespaces are a group in which different pods run. Let's not go into pods and all. Okay, leave it. So then IBM came up with namespaces and C groups, and then finally our Docker came into existence in 2013. Docker provides simple user tools and images containers go up mainstream. There is a documentary on Docker and Kubernetes, different documentaries. So you can go to Netflix. I think Netflix, or I don't know who have introduced it, but I've seen it. It's pretty good. If you have that much passion for Docker and DevOps tools, you can go through it. It's really good. It's in the form of documentaries where Google people and all the people who were included in Docker and containers, they have made a documentary. They have given their speech and their talks there. You can understand how the Docker came into existence. From there, you will get a clear picture, cut through idea. So you can go through this or search just on YouTube Docker documentary and hope you will find it. I'm not sure, just you need to find this. Okay, here comes our Docker Hub. Let's log into our Docker Hub. It's a simple process, right? As you have made your GitHub account or any other account, it's simple, right? Let me sign in. It took the credentials automatically, I think. This is my registry. And if you will log in or make your account, it will be Docker Hub will give you your free registry, one free registry. So this is my registry and this is my images. If you want to check out my images, you can go through this profile. So these are the images. So let me show you the command which we can install the Docker on Ubuntu. So it's simple. Sudo apt install Docker. With this simple command, you can install on Docker on Ubuntu, and this is a minimum because on Docker documentation you can go through this. You can go through this documentation if you are on Windows, if you are on Linux. Let me show you. If you are on Ubuntu, go through the Debian version. Okay, here is a Debian version. Let me show you for Windows and Mac as well. So here there is installation step for Linux, for macOS and for Windows. Check it out here. And for Docker, there is a two thing, Docker desktop and Docker engine. On Ubuntu, I would prefer for a beginner perspective, or if you are just starting out, don't do anything. Just if you have Linux or Ubuntu, it's easiest. Just install with this simple command, because if you install through there, it will be highly good and it will be a latest version. but it's not useful for you. This much big application is not useful for you for now. We just want to pull and push the images and all. We'll do the basic command implementation and the basic Dockerfile and not the advanced stuff here. So for you, this command will be enough. Okay. So here you can see it's installing for now. Let me see if it gets installed. Okay, it's processing. If you are on Windows, install putty, and on putty you can install Docker, right? And there is command for Windows as well. Just check it out there. I just don't want to make this video more long by installing on different OS. There's a command given guided. This doc can explain better than me. I think here, see, you can just copy this command and paste it on your putty CLI. Simple commands. Okay. And if you got any issues, let me know in the comment section, or I would highly recommend to post it on in the Slack channel of Docker or on the Stack Overflow. Right. Okay, let's get on the Docker. So let's pull the image from Docker Hub. We will use this image, Django application. So I have made a Django to-do application with the use of Django library. It's simple application. Basically, I have just cloned the project from some person, and I don't know Python much. Let me show you the file. Okay, let's install it. Let's pull the image. So it will take some time. In this time, let me explain you Docker Compose and Docker Daemon. What is Docker Swarm? These are high-level topics. I will just try to explain you. There are many concepts in Docker, like Docker networking, Docker volumes and binds. There is many things to learn. Here we will discuss basic stuff. This is a one-shot video, so we will discuss more of a basic stuff, and I will try to make a base for you to learn everything. So just check out, if you want to learn more about Docker, just check out other videos, or if possible I will include the link in the description as well. It's completed. So let's run it. Okay, so our image is up and running now. Okay, can you see this? Congratulations, you have successfully run your Docker image. Please like, share and subscribe. Please like, share and subscribe to this channel if you have gained any knowledge from this tutorial. Okay, let's get back to work. So you saw the image, right? Let me show you the implementation and what's going on behind the curtain. Let me show you that. Okay. So first you need to go through this URL. The link will be in the description. You can check it out from there. So first we will clone the repository. Let me show you first. So this will be the repo. We will clone it. Okay, it's cloned. Now let's change the directory. Let's see its component in VS Code. It's taking some time. Okay, it's up and running now. So first is main.go. Can you see this? Simple Go application. We have used a simple Go application here. Just go web server, which will give you a message like, congratulations, you have successfully run your image. Please like, share and subscribe. Simple. I just, if you are a complete beginner, it will be useful for you. If I could also take the calculator example or any other example or any other complex example, but I want to keep it as minimal as possible, so it can be useful for beginners as well. Okay, let's write. Okay, let me talk about Dockerfile and what is Dockerfile. So to run this, see. So what's the issue now? See, as I have told you, we have our box. We have our box ready. Container is ready. Means we will prepare it. No worries. First, we need what we will require first source code, right? We need source code, and we have that. We got that source code. Now we want a local environment setup. If I have a local environment, then this to create this box is like a piece of cake, right? You can just spin up your container with local environment and source code in a minute in just a single command. So let's see how we can prepare our local environment. So it's simple. Just think like what you see. You have just installed a new operating system, and now what you will require on this operating system to run your source code. First, you need your source code. First, you need operating system, right? Second, you need a source code. Third, you will install all the dependencies and libraries needed. And fourth, it will be a command to run your application, right? The four command, the four simple steps. Now, let's prepare our Dockerfile. And the preparation of this local environment is known as Dockerfile. Simple. Nothing else, nothing big. Right? We will create a Dockerfile which is as minimal as possible, which is as easy as possible. Let me show you first that. Let's build it. Okay. So first, what you will have, understand this. You have a source code and you have a new application, a new PC. Now, first to run this application, you need a operating system, or Go runtime, or if you have a Java application, you need Java runtime. Right? Dockerfile. So first we will need a runtime. For Go, we will need a Go runtime. First, we will have a Golang image. Let's take it 1.20. Any image you want, but to run this application, you need Golang image, and the version is specified on how smoothly this code base can run on this version, right? I know it will run smoothly on 1.20. Next we will create a working directory on which we will store our code base. So I generally don't remember this syntax. It's just come from practice. Just practice again and again. Build Dockerfile for different application, and if you don't remember this, you don't get extra point to remember these files, this syntax or Dockerfile. Don't remember Docker. Don't rant or don't cramp it. Don't try to remember it. Simple. Don't try to remember the Dockerfile. Right? You will learn it when you build it again and again. Right? Simple. Let's first create our working directory, and now I will copy the code base from the directory to the container. So we have first we will give first we will give a path to the source code, and then the destination. So our source code is available here. So we will type here dot which ensures the code base is here, and the container is also here. So again we will have a dot. Okay. Now let's build the code. Okay. For this, on this line, don't go deep. On this line, don't go deep. I will just give you a brief of what this line says. Right? It will just build our core application. So this line is completed. Don't go deep again. Again, I am saying you that. Don't go in deep. In this line, we are just executing the code. We are just building our code, We are just building our code, nothing else. It will ensure that the code runs smoothly on every platform like Linux, Windows or Mac. Doesn't matter, right? Nothing else. Okay, so let's move to the next line. Now we will make our main file executable. When the container starts, this file will execute. So the command for that is, so to execute a command, we will give a command and the main file, right? This will be our final product, right? So I forgot to add the double inverted commas. So the file, let me explain you again. First, we need an image. To pull the image from the Docker Hub, we use from command, right? You will get all this on the Docker documentation and just try to go through all the syntax. Don't remember it. Again, don't remember it, please. Golang, we will take an image of Golang to make the Go code executable. Then we will make a working directory in which we will store our code, right? And now I am going to copy my code from the directory to the container. And now let's install all the dependencies or all the modules Go have. But this is a simple Go application. We don't have any module to install. Then now, but to keep this line, it will be a good practice or a best practice, as I would say. And this will make the Go code build. It will build the code, and now at last we will execute our main file when the container starts. Okay, so our Dockerfile is ready. Let's build it. Now to start the container, is a piece of cake, right? Not a big deal. Let's start the container. Let's build the container first. Let's see if we have any other images. I'm unsure why is this taking so much time. Let's run it again. This is the image we have built and run it for the demo purpose as earlier. This is the same image. See, go Docker demo. Okay. Now let's build over this image. Okay. Let's give it a tag or a name, I would say. This will be my username and this will be the name. Let's give it name as my app. My app would be quite better. Okay, so let's split, or let's give it a same name. Possible? Let's see. Because the image and the code base is the same. Let me show you first. Okay, forgot to hit the dot. Okay, so the building process is started. Let's wait for a minute. Okay, so our image is built. Let's run it. Let's run our image. Okay, I made a mistake in the name. Can you see this? Congratulations, you have successfully run your Docker image. Please like, share and subscribe to this channel. Okay, please like and subscribe. And the image is successfully built and we can run the image as well. You can see this. Great. Congratulations for building your first image and successfully running it. Okay. Let's see some commands. Sudo docker images will give us all the images stored in Docker daemon. So now what is Docker daemon? Docker daemon is like a manager of Docker. It will create image, remove image, it will take care of the network stuff. You can't work on Docker without Docker daemon. If for now, if I stop the Docker, let's stop the Docker daemon. See, here we have stopped the Docker. So, what is stopped now? The Docker daemon is stopped, right? Here we have stopped the Docker daemon. Now we will start it again. See, our file is now not running, I think. Our image is not running, I think. Let me show you. See, failed, right? Why? Because Docker daemon was Docker daemon is a manager. It's playing its role behind the curtain. Let me start it again. Can't work it without start. Okay, so it will start. It will show you all the images, right? Let me show you another one. Wait, let me run it first. Okay, so our image is up and running now. Let me show you again. Our image is running now. Here we can see the running images. So sudo docker ps will give the list of the running Docker containers. See, created 18 seconds ago, status to 14 seconds, on which port, etc. etc. Right. Now sudo docker ps -a will give the information of the of the running container and the stop container. See, here we had the running container and the stop container here. Exited about 2 minutes ago and 12 hours ago. Can you see that? Fine. Now let me ask you, what's the difference between docker ps -a and docker images? It will give you the images name and all. It will give you the same. The difference is status and all. No. Sudo docker ps -a will give you the running and the stopped images, whereas sudo docker images will give you all the images that are stored in Docker daemon. That is the main difference, right? Okay. Let's see the images. Okay, so can you see this? Here on this image, which we have built 4 minutes ago, on this image, it is 913 MB. The size is 913 MB. So in companies try to make things as small as possible because they want to ensure that there is a space. Because if you are working on AWS will charge you for more space. So how can I make this? Make 913 to at least 50 MB or less. How can I do this? I want to make this as small as possible. Let's do that. So in Docker we have one concept, multi-stage, multi-build. So you can divide your Docker images in different stages, like stage 1, stage 2, and let me show you. So this will be the stage 1, and and this will be the stage 2. Stage 1. This will be the stage 2. Stage 1 will be the build stage, and it will be the final stage. So this is a interview question. Mostly recruiter asks this, that how many more stages can be done in a Dockerfile. The answer is infinite. You can build as many stages as possible, right? And the least number of stages are 1. Okay. So the least number of the stages is 1, which we have made the Dockerfile as you have seen earlier. Now we will make a Dockerfile which will have 2 stages. First we will build the image, second we will build the final stage. So what I need to run my image? I want to run my image. So what I need? I just need a binary of my source code. I don't need my source code even. I just need my binary to run the source code. And that I will do in this. First I will get an image. I will make a working directory. I will make a source code. And then at the final I will bring or extract my binaries of the source code here in stage 2. And I will run it. In this way, I can bring my image to less than 50 MB. Let me show you. It will not be more than 25 MB. I guarantee you. Let me show you now. Let's build our Docker image. The stage 2 of the Docker image. We are on our Dockerfile. So this will be the stage 1. Which is a build stage. Right? Here we will first we will download the image. But the case here is we will give it a name builder. First stage is a build stage, so we will give it a name builder. Now we will have a working directory. We will copy our code as well. We will download the co module and build our code as well. But we will not run the executable. We will not run the file. Here comes our stage 2. We will get a small file as small as possible. We will get an alpine image. Just to run the code, we will get an alpine image. Now we will create a working directory as well. Now we will copy our final binaries from the builder. Copy from builder. We will give the destination. We will give the path and the destination, and we will execute our file. Okay, so I forgot to add the equals to sign here. The syntax is, I told you, don't remember the syntax, just take it from the Docker documentation. I will show you the syntax documentation as well. I will give the link in the description, so check it out from there. Okay, so our image is ready. Dockerfile is ready. Now let's build the image. Let's see the results. So here we are. Let's build our image. -c is a take, to take the image. So first I will give my username, because we want to push this image to the Docker hub, right? So first give your username and the image name. Image name is Dockerfile. Okay, and the Dockerfile is available here, so we will give a dot here. And if your Dockerfile is available in some other repository or in some other directory, give the destination, give the path of the Dockerfile. Okay, let's build it. It will not take much time as earlier. Let's run our image. What was the name? I forgot the name. Okay, so here was name. Let's see. So our image is on localhost 8080. Again, the image is up and running. Can you see that? The same image. Let me show you the space it took. It's up and running. Let me show you the image space it took 14 MB, just 14 MB. And the other image we have made, it was 913 MB, right? See, can you see the difference? It's not more than 15 MB. We can keep it at 3 to 5 MB as well. So it's your assignment, try to make it at 5 MB. Let's see if you can make it. And make a pull request on my repo, and I will review your PR and merge it. Okay. Let's see other command as well. Let's now push this image to repository. So sudo Iqra 11. First you need to log in to your Docker hub on CLI. So I already had credentials, but if you don't have, so it will ask for a username first. Give your username. It will ask your password. Give your password, and it will be login. It will give this message: login succeeded. Okay, so let's push our image. So to push the image, it's just a simple command. Let me get the name of the image as well. Push and the name of the image. Simple. So it's now preparing. Let's wait for a minute. Our image is pushed. Let's see the Docker hub. Let's see on Docker hub. It will say it's updated few minutes ago, few seconds ago. Let's see that first. Here. Can you see that? A minute ago. Right. Okay. So we have built the image, we have run the image, we have pulled the image, we have pushed the image, we have seen Docker ps command, we have seen Docker images command. Let's see another command as well. So if you want to remove the command, first if you want to stop the container, let's stop the container. Stop, and the name of the container. Okay, so first I should make it run, right? Let's run it. It's running. Let's see if it's running or not. It's running. It's up and running. 7 seconds. Let's stop it. So here our image is up and running. Let me show you how to stop the container. First run sudo docker ps. PS will give you all the running images as I have told you. So let's run this now, and the container ID. Sorry, container ID. You will get the ID in return, so it means the container is stopped successfully. Let's see this. See, here it is exited. Let's see on the web. Can you see that? It's now not running. The image is not running. Stopped. Okay. What if I want to? Let me show you. Let me start the container again and show you the kill command. If you want to, if the container is running and if you want to remove it directly, you can't remove it directly. First, you need to give container a kill signal, and after a kill signal, it will take down the container, and after that you can run the remove command. So first, let's kill the container. Okay, so I think the ID is changed. Yes, it should be because we have run it again, right? It's killed. Let me see this. See, the command is exited, and let's see on the web as well. See, again it's not running. Okay, but still you will see the image not in the running state. The image is not in the running state, so you can't see the image here, but you can see image on the stopped image, as I know. See, we have stopped it 33 seconds ago. About a minute ago created and exited 33 seconds ago. Okay, but now I want to remove this. I want to remove this container. I don't want it on my server anymore. Let me remove it now. It's removed. Let me show you as well. Image or container. Let's start our container. Okay, here it is. Okay, so it's running now. See, it was there, right? 0AB. You can't see this. The same number. You can't see this, right? Okay, and if you want to kill the container and if you want to remove the container and there are some issues and you can't remove the container, you can add the flag like -f. It's like sudo docker remove -f. You can force it to remove. If you know more about GitHub, you would probably heard it to push your changes to the local to the remote. Sometimes you use -f because sometimes there are some issues. But use this -f flag for force flag carefully because sometimes it makes some changes and it destroys something which will not recoverable or there will not be a backup for that. Okay. Okay. For now we don't need to use this. Okay. And few other things, let me show you that. As I have told you earlier, you don't need to remember commands. Let me show you something. If you don't remember the run command, right? But you remember in every command we have Docker, right? At first, and now you want to run your image and you don't know how to complete your command. So for that, we have help. Here, if you are in a company and you forgot the flags as well, so you can take a help from here in anything like let's remove image. With the help for that. Okay. See, I told you about force, right? Here it is. Minus F, minus force. You can use both options. Any option. If you want force the removal of a running container. If the container is running and you want to remove it immediately without killing it, you can use this command. Okay. Let me show you the Docker documentation as well. Let me show you the Docker documentation as well. So here, refer to the documentation, anything. If you want to search about anything, like you don't, in this session we didn't learn about anything about mounts, volume mounts, and network stuff. There is so much. I can make a 2 to 3 hour tutorial on Docker networks. It literally is a vast topic, right? So let's search about that one. And I would, if you want to know more about Docker, you can learn on network stuff, on volume stuff, etc. Also, let me show you first this. See, networking uses, and you got all the subtopics here. Okay, got it. We have commands, we have examples, easy. This will be the purest or the best way, straight way to learn Docker is to go through the documentation. If you want to learn anything, if you want to start to learn anything, first get basics from YouTube or anywhere, then go through documentation. If you want to learn the advanced stuff, go through documentation. Documentation is filled with everything. Like if you want to learn Git, if you want to learn Kubernetes is a vast community. Also, if you want to, if you have learned enough about Docker and now you are like, let's get this feature on Docker, so you can also, let me go through. If you are like, let's introduce this feature in Docker Hub or in Docker. So you can go through the Docker repository and you can go through the source code as well. It's available for everyone. You can make changes. You can talk to contributors and maintainers then. So we are in the Docker repository of GitHub. So here we have 110. We have 110 repository, and you can see that. First, don't be overwhelmed by seeing these repositories. I know you don't know anything about Docker. When I started, I didn't know anything about Docker. Right? I am still learning. Right? You just need to go through it. You don't need to learn everything. There is huge stock of knowledge present in the internet. You don't need to cramp it. You don't need to learn it. Just go through it. You will get an idea, right? If you got any type of fix or link fix on the documentation side, you can make changes in the documentation page. So to do, there is enough work. And if you have any questions about Docker, you can go through the Docker community form. You will get answers as quickly as possible. So go through this as well. And let me give you one assignment. Here I am using again and again sudo, which is not a good practice, but it was only for demo purpose, so I just install it and use it directly and didn't make any changes, right? So the assignment is learn how to use Docker without using super user. Why? Because in companies you don't have super user access, right? You are working under someone, so you don't have super user access. You need to run your Docker containers, and it's possible. you can run Docker containers without using super. So make changes in your terminal. What change is required? Learn it from internet, learn it from YouTube, anywhere. Just remove sudo word and run your Docker containers. Right? This is your task. Second, build Dockerfile. Build the stages in the Dockerfile. So learn how to make changes, how to go through the documentation, go through the repository of Docker. If you want to learn more about Docker, go through volumes and networking stuff of Docker. You will get a good idea. And also, before Docker, it would be highly useful if you have knowledge about Linux, because containers come from the Linux. The idea of the container was started from the idea of Docker container started from Linux. It was taken from the Linux, right? So it will be highly useful if you have some knowledge of networking stuff, if you have knowledge of system administration stuff like Linux administrator. It will be highly useful. So that's it for today. I hope you gained the knowledge from this video. If you had, please like, share and subscribe to this channel. Okay, so let's meet in the next session. Thank you. Have a nice day.